Yeah, myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to study what are the law of movements and how to apply laws of movements in practical applications or real field problems. Whenever we want to calculate the movement, what is the law of movement? The law of movement is nothing but algebraic sum of all moments about any arbitrary point equal to 0. That is, in mathematically, sigma m equal to 0. So here, what is the algebraic sum? The another meaning of algebraic sum of all moments equal to 0. The physical meaning of this mathematical equation is that the body will be in equilibrium momentarily in equilibrium. The effect of the moment causes rotary motion to the body. So, in order to maintain the equilibrium, that means the body will be in a stable condition or not to be in movement, then mathematically sigma m equal to 0 should be equal to 0. If sigma m equal to 0, it involves there are two types of movements. One is clockwise movement, another one is anti-clockwise movement. The clockwise movement, the rotary motion in clockwise direction, then it is known as the clockwise movement. The rotary motion is in counterclockwise direction, then it is known as anti-clockwise movement. Whenever the sum of clockwise movements equal to the sum of anti-clockwise movements, that means the algebraic sum of clockwise and anti-clockwise movements equal to 0, then the body is in equilibrium, momentarily in equilibrium. So the moment is nothing but the moment of a force is perpendicular. The moment of a force is the perpendicular distance to the line of action of the force multiplied by the size of the force. The meaning is that moment m equal to force times distance, where F is the force, the action of the force, and the D should be perpendicular distance to the point where we are going to find out. If we consider the figures here, this is the force. In this figure, if you see, the force which is acting here downward direction when you are applying the pedaling, the wheel, cycling, the force and the distance to the pivot point. This force causes the force into distance, perpendicular distance. This moment causes the rotary motion of the pedal. Generally, when we are learning the cycle or bicycle or two-wheeler, bicycle especially, we don't know the concept of the moment of a force, the moment. But we apply such a way that the cycle can move. We can move forward on a cycle. That means what we are going to apply here, the force we are applying, and the cycle, the pedal is designed such a way that the distance which is representing here, that is the fulcrum, that is the perpendicular distance, the fulcrum, and the where you are applying the force by using your foot here, the force into perpendicular distance, then it gives the moment. So moment is measured in terms of Newton meters or Newton millimeter. So moment of a force, Newton meter, equal to force times force in newtons and the perpendicular distance in meters. That's why Newton meter. If moment of a force unit becomes Newton millimeter, that means force is in newtons and the perpendicular distance and the D is in millimeters. If D is in millimeters, if D in millimeters, then the moment of a force becomes Newton millimeter. So the moment of a force, once again, the moment of a force is defined as, or the moment of force is, the effect of the moment of a force is the rotary motion of the body. So here, whenever the body is rotating, it is under movement. We may call it as here, unless until some external force acts. Because of action of the force, the body, the effect of that force gives the rotary motion. So the moment m equal to F into D. Thus we can calculate the moment of a force. That is a calculation of a moment. It is not momentum. Momentum is entirely different from moment. Okay, momentum is entirely different from moment. Here in this figure, we consider the cycle. The cycle is the foot is applied here, the force, and here, and also fulcrum at the distance. Suppose if we want to give less application of the force, we have to keep the foot rest such a way that such a distance. So if you increase the length, one very important point is that if the length of the pedal, the distance is increased, if the distance, that the perpendicular distance is increased, then the force needed is less force, in comparison to the force applied at the distance. If a perpendicular distance increases, d increases, the force required to give movement will be reduced minimum. If d decreases, F is required high, more F is required. So how much d is required? It is the optimum distance. It is required to design the pedal of the cycle, the length of the pedal of the cycle in such a way that it should be optimum, such a way that the F required is optimum, F required is minimum. Okay, so that the length of the pedal should be if it is increased, so that you need less force, less effort, less energy. This is the zone in order to pedal design. This is the where the length of the pedal, the length of the pivot distance is increased in such a way that even the older people, because older people means having less energy, for them also it can be suitable to cycle. Okay, so that here the concept, it is the application, the design of the length of the pedal wheel, the pedal here where we are applying here, the length of the pedal rod is highly important. Such is highly important for cyclists, those who are going fast, so that we can travel more distances with less, without getting tiredness. All right. Now some of the one or more important application example here, it is the moment of a force here is used. One more application is used to measure how hard something is being turned or twisted about a turning movement. The moment of a force is used to measure how hard something is being turned or twisted to about a turning point. Here the turning point is here, the nut, tightening the nut, or tightening this, or loosening, or if you want to unscrewing or screwing, or tightening or untightening, you have to apply what? Moment force. That force causes the moment such a way that gives the torque, the twisting movement causes to rotate the tightening of the screw. So here it depends upon how much big force is and how long the lever is. F and D, this F and D affects how long the lever is, that the D is the distance, and how big the force is. So the turning point is often called the pivot or fulcrum. Actually the turning point is, where is the turning point or rotating point is? It is the pivot point or the fulcrum, at which when you apply the force, the way along that this turning point rotates, the pivot point rotates. Here in this figure you can see. So the moment of the force F equal to the moment of the force M equal to F times the distance, that is the D here. D is the distance, we can see. So F is the force. So here we are applying what? The concept of moment principle is applicable here. Okay, and this is one of the example of the here. So here we are applying downwards. So the direction of the rotation, the clockwise, or the direction of this is the what? Counterclockwise movement from my end. The counterclockwise movement, this is the F we are pulling. If you apply the momentum force in upward direction, then what happened? The turning moment will be opposite direction. Okay, this is what that means. The turning moment or the moment is depends upon two things. One is F, another one is D. So M equal to F times D. M increases in proportional to what? D, proportional to D. Alright. And but what is the relation between F and D? It is inversely proportional. So F equal to M by D. So F and D relation is F is inversely proportional to D. So when d increases, when d distance increases, F becomes low. F requires, the requirement of force is low. And when d decreases, the requirement of the force is high in order to give the movement turning effect. Alright. So here, there are two things. Movement is dependent upon two parameters. One is force, another one is distance. There is a perpendicular distance. Alright. And here, one more thing is that here, this m equal to F times t. The one more application of this moment principle is that turning the cap. If you want to tightening or loosening the cap of a bottle, so this moment of force is required. Moment is highly required. All right. Let us see in these two figures the perpendicular distance, measuring the perpendicular distance we are covering here. So the perpendicular distance is the shortest distance. The shortest distance from the pivot to the line of the direction of the force. That is what here the perpendicular distance. How to measure the perpendicular distance? The perpendicular distance is always the line of action of the force to the fulcrum. Similarly, what is the distance in this case? In this figure, this is the pivot point and the line of direction of the force. This is the distance. In this case, this is the distance. This distance is the perpendicular distance. So, what is the perpendicular distance? We need 2 points between them is the distance. One is the pivot point, another one is line of action of the force. We should not forget, this is the concept. So, then, after measuring the force and the distance, movement can be calculated, that is F times d, that is the movement. So, the movement is clockwise or anti-clockwise. How can we know it? The direction of the rotation of the lever in this case. Whereas in this case, the pedal, the direction of the perpendicular distance. So why here it is important? Very important here. Suppose if the perpendicular distance in this, the pedal is upward, is in this direction, but the other direction of the force is important. It is not the point where you are here. The direction of the force, perpendicular line. Suppose this is the point of the pedal. The person's foot rest, this is the perpendicular distance. Okay. If the moment, actually the pedal is always rotating in 360 degree. Here it is. Now important concept, very important here. The maximum distance when it is the angle is made with the pivot is, here it is, d, 0 degrees or 180 degree. The moment the pedal goes this direction, this is the pedal, your footrest point. Here is the footrest point, that's why distance is high. So the distance, footrest point is here. What is the distance? Distance reduces d. And here is the d, here another d. Here we can make a d1, in this case d2. The third case, this is the pivot point or fulcrum point of your pedal. Now, pay attention here. This is the pivot point of your pedal when it is horizontal. Here, this is the force applied here. That is a D1. Now I am coming to position here. Now this is now becomes a D2. The distance is reduced to D2. Now the pedal position, your position of the pedal cycle wheel, that is bicycle is now is the position vertical. That is 90 degree. Is the 90 degree. Yes, this is the position. Now what is the distance d here? When pedal is here at this position, what is the distance d? D equal to 0. That is a d3 case. Now we know the F equal to m by d. When the pedal is in vertical position, this is the pivot. What is the d equal to 0? How much force is required? The force is required very high level. Now if you apply the force in vertical direction, what will happen? The distance d equal to 0. F requires how much? Infinity. F becomes infinity. At that time what we will do? We will change the position of our foot. Yes, our foot will change. Then it becomes horizontal. We'll push in this direction, again perpendicular. Now the direction of the force at this point of the wheel, what we will do? We'll keep in that direction, we'll push. Alright. At that time, what is the distance? Now perpendicular distance is the d. At this position horizontal of the wheel, the perpendicular distance is here, d1. Now, when it is vertical, the pedal rod is in vertical position. Now what you will push in this direction, horizontal direction. Then it moves. That's why it becomes a d. If you apply the force in vertical direction downwards, that means d3, that is d3 becomes 0. The d becomes 0, that is called here we consider d3 at this position, or d becomes 0, here d2, as d equal to d2, and here d equal to d1. So the d equal to d1, the position needs what? Less force is required. That's when pedal wheel is horizontal, you need less force if you apply the perpendicular distance. When this position, what you will do? You will push in this direction, not in this direction you apply. Now what about the position? The direction of the position is here d, here also d. So in that manner, the wheel will keep it, always will maintain the d. The distance remains constant. That's why we need same constant force to rotate. So suppose our wheel is, we have the body mechanism, the legs position is such a way that when it is down, when the foot rest is applying downwards, we need less force because the tendency is like that. When the wheel is like that, you need a horizontal force. Okay, in that manner moves the wheels, pedal wheels, cycle wheel. When the position is here, what we will do? We will apply in this direction so that the wheel, the distance d will maintain same distance. So if you apply force exactly when the rod is vertical direction, you apply the force downwards, the d becomes 0, the distance becomes 0, the force required in order to give the moment is very high, that is the infinity level. Then at that time, what we will change the angle of our foot and push the rod in this direction. So similarly, we will maintain this is horizontal, we can apply more force. So not more force, the less force is required in order to give the more momentum when the pedal wheel is in horizontal direction. This is the case study. So at this point, if you apply more force immediately, it affects more output, more momentum takes place. But the position here, the pedal wheel is at this position, you need more force, but less momentum takes place. For in order to give the same constant momentum, we need more force. The same force applied for this case, and for this case, if you apply it, but it won't be applicable. Same moment effect doesn't come out. So in that manner, the concept of movement principle is highly important for effective getting movement. So thus, we can increase the speed of the bicycle. Yes, this is the wheel. This is what a distance measured, the perpendicular distance of position. For this case, d is high. For this case, d is low, which is very small d. When the position of the crank here, the wheel, pedal rod is in this angle, inclination. Now, here in this case, the point is that one more important example for understanding the concept of the movement, and we can also measure the direction of the movement. Here it is. Here, tightening the screw, this is the F. F is the force, and where is the D? This the D is the perpendicular distance. It causes which movement? The movement of the direction about the pivot point, about the nut here or fulcrum. This is in clockwise direction. That is M equal to F times D. M equal to F into D. This F is the force which acts downwards this distance. Yeah, the direction of the movement is in the direction because the force is in downwards. The distance doesn't have any direction here. The distance is same. The distance, the force direction affects the movement direction. What is the movement? This is in this direction because the F is in this direction. All right. The next one is seesaw example. Here the seesaw law of movements. What is the law of movement? States that or equilibrium or balance. What is the equilibrium? It is the balancing, no motion, equilibrium position, balancing position. The clockwise movements are equal to the anti-clockwise movements. So here the clockwise movements, the distance, known force attached, the pivot point or fulcrum point. This is the fulcrum point where we are attached to the weights here and here another weight. Okay. Now, by using the law of movements, we can find out unknown distance and unknown forces which are acting on another side. So by using the law of movements, that means clockwise movements equal to anti-clockwise movements. If you do it, this principle, if you use this principle, if you apply this principle, we can find out the unknown force. Suppose this is the known force W1. This unknown force W2 has to be found. We know the distance of known force to the pivot and the distance from the position to the fulcrum, this known force. These two are distances known, D1 and D2. How to find out W2? Suppose W1 value is 10 newtons and the D1 equal to 5. D1 equal to 50 millimeters. D2 equal to some 100 millimeters. Then what is the value of W2? Now apply the law of movements. Clockwise movements equal to anti-clockwise movements. Now clockwise movement is, what is the clockwise movement? This is the clockwise position. W2 is acting. W2 times D2, that is 100. D2 equal to W1 times, what is the clockwise? This is anti-clockwise movement. W1 times D1. Substitute here W2 D2. W2 is the unknown. What is the D2? 100 millimeters. W1 is the known, 10. D1 is 50 millimeters. Now from this we can get it. What about W2? The W2 becomes, how much W2 is? 100 get cancelled. W2 becomes 5 newtons. So the unknown weight can be calculated by using law of movements. So by using law of movements, you find out W2, that W2 gives complete balancing in proportional to the distance where it is acting W1. The W1 is acting 10 newtons at a distance of 50 millimeters. So if W2 is acting at a distance of 100 millimeters, how much weight is required to balance the effect of W1 and D1? The movement W1 D1 should be balanced. The movement caused by W1 should be balanced by W2. For that, how much distance? Though we already kept D2 distance, so 100 millimeters. But how much weight is required? At the distance of 100 millimeters, W2 becomes how much? 5 newtons. So if you use a 5 newtons weight at a distance of 100 millimeters, that the moment caused by W2 D2 is equal to the moment caused by, or the effect of the force of W1 at a distance of D1. Alright. So by using law of movements, we can calculate the unknown force. That's what. Alright. Here we can see the clockwise movements or anti-clockwise movements, unknown force can be calculated. This is the example. The load in the bottom is 500 newtons, and which is acting at a distance of, as the pivot is there, the pivot point, this is the pivot point, at a distance of 0.2 meters. So the point of load where you are applying F, and it is acting at a distance, it is at a distance of the load carrying, this is the hands carrying, is at a distance of 1 meter. How much force is required to lift the load in the borrow? Okay. Apply the law of movements, that clockwise movements equal to anti-clockwise movement. The clockwise movement equal to, this is the clockwise movement. The clockwise movement equal to F into 1. Okay. In this figure, if you understand from my side about this pivot point, yes, the clockwise movement equal to F into 1, where the F is the force. Here the F is the force, F into 1 meter. Okay, that F into 1 meter equal to anti-clockwise movements. The anti-clockwise movements is 500 newtons in times this 0.2 meter. Then F equal to how much? That is 100 newtons. 100 newtons required to lift the force here, to lift the load which is in borrow. Alright. So to lift the load we need. We may ask me here, if we reduce the distance, what will happen here? If you reduce the distance F, then F increases, then what? How can we how to reduce this force F? We can reduce the force if we decrease the distance. How it becomes here? Or if you increase the more if you increase the more distance, if it is the distance, instead of 1 meter, you keep it as a 2 meters. If it is 2 meters, we can reduce the load off of this F. Suppose the distance is 2 meters, then F into 2 equal to 500 times 0.2. Then F equal to 1, that is 100. 5, this is 50, 100 by 2. 100 by 2, then what will happen? It is 50 newtons. So by increasing the distance D, what is happening? Reduce the moment force, the force caused required to lift the load. F will be reduced to 50 newtons. Alright. So in this manner, we can find out, or we can calculate the unknown force or lifting, just lift or to balance it. This is for balancing, exactly. Okay, for balancing are required. Okay, next, the law of movements. Then by using the law of movements to calculate the size and position of the counterweight that needed to balance the load, that is the main concept law of movements are. So to balance, here the meaning of the balance movement is that, because this concept highly useful in unbalancing of or finding out the unbalanced forces of engines, multi-cylinder engines. Okay, in multi-cylinder engine, different forces acts. It causes the movements or couples. So how to balance it? So to find out the position of the counterweights, such a way that to balance the unbalanced forces. And these laws of movements are highly useful. Now in this case, by using the law of movements, we can also find out, especially in cranes, forces on a crane. Here, how much weight you are going to be carried, that is very, very important. The carry, where to place these loads, the counterbalance weights. These are the counterbalance weights. If these counterbalance weights are not there, what will happen? If F1 into D1 equal to F2 into D2, suppose. If D2 is not there, if D2 is 0, then what happens? F1 into D1 equal to this, there is no, this F1 D1 becomes 0. That moment becomes, do you think moment becomes 0? No. The effect is that it will break, failure, it will affect. To balance, that means F1 D1, the moment doesn't take place. If a movement is not there, what will happen here? The force, it affects, that force affects to damage the structure. The point is that in order to balance, balancing means in order to withstand equal, if you want to carry, you can take it. What is required if you want to take it? We have to make it counterweights. For this case study, where is the fulcrum point? This is the fulcrum point. About this fulcrum point, this is the fulcrum point. About this fulcrum point, this movement takes place. The weight, load into distance. The load, that is the load is F here, F1. The distance is D1. And the load, here it is acting, counterweights, it is D2. The load is acting downwards, F2. So that means F1 into D1 equal to F2 times D2. Clockwise movements are from this here, in this direction, the anti-clockwise movement equal to clockwise movements. Then only complete balancing takes place. If it is not, what will happen? Unbalancing. Unbalancing means, suppose F1 D1 is greater than F2 D2. What will happen? F1 D1 is greater means that it will bend. The bending movement takes place. Bending takes place about this point. It will bend down. Okay. Or if F1 D1 is less than F2 D2, then what happened? Bending takes place in this direction. F2 D2 is more weight. So it's like a seesaw. It goes down. F2 D2 downwards. It moves up. We need to balance. That means F1 D1 equal to F2 D2. That should be there. F1 D1 equal to F2 D2. So these are the practical examples of law of movements. Okay, let us see. This is one more example, very, very important example. The forces on bridge. In this case, forces on bridge. This is a bridge. Fulcrum point is here. So these are the points here. The lorry is carrying here in this. Then the weight of the lorry on this off of the bridge causes it to turn around the support. The weight of the bridge, it turn around the support. At this support, it will turn. So how to balance it? Here the reaction forces should make it. When it is pushing down, we have to reaction forces such a way that, understand, in this, when it is pushing down, immediately reaction takes place. It should be balanced. So the force required to secure the bridge can be calculated by using the law of movements, that is clockwise movements equal to counterclockwise movements. So these are the examples. If the cab here, very important, in this figure 1, above figure, the pivot is this side. How it will be balanced? If it is alone, what will happen? It turns down. No weight is there. The pivot, but then how to be balanced? By attaching this point. The clockwise and counterclockwise direction. The cab provides the force to turn the load back up. Application of the law helps to calculate the load distribution and the maximum loads. Yes, counterclockwise and clockwise here movements about this pivot point. This is the clockwise movement and it is the anti-clockwise movement. Such as it will be balanced. So now in the C we can see the force, the direction of the movement, clockwise movement, F into L. Yeah, spanner in order to tightening. So here also we can see here the forces, movements and equilibrium. Okay. Otherwise it will happen. The weight is, when it is downwards, the motion. Here it is downwards way, the acted. Now it is coming down. Downwards is movement, unbalancing. Now here you can see the force F into, this is also direction, the clockwise, yeah. Both are in complete clockwise direction. That's why the movement, you can see the direction of the movement. In order to balance it is downwards and F into L about this point is clockwise and about this direction it is in clockwise direction, F into x by 2. F into x by 2. Alright. Then what is happen here? It is clockwise, it is in counterclockwise. It is also counterclockwise. Rotation takes place. To balance this one, what to do? You have to apply F1, F here, and it is x by 2. Then it will be the direction arm. To make it in balance, the direction of the force should be downwards. Otherwise, it is unbalanced. So, in this session, we have studied with practical examples how to apply the law of movements and how to calculate the law, how to calculate the unknown force in order to balance, or how to calculate the counterweights and the location of the counterweights to maintain the moment equilibrium. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.